Problem number 2. Expand 1 mole of a monoatomic gas initially at 8 kilopascal and 600 Kelvin from initial volume Vi equal to 1 cubic meter to final volume Vf equal to 2 cubic meter. At any instant during the expansion, the pressure P and volume V of the gas are related by the equation P equal to 5 exponential of Vi minus V over A with P in kilopascals, Vi and V in cubic meters, and the value of A equal to 1 cubic meters. What are the final pressure and the temperature of the gas? Third question, how much work is done by the gas during the expansion? And the last question, what is change in entropy delta S for the expansion? So in this question, we have to answer for these 4 subdivisions. Clear? First of all, let's write the given first. So what is given in this question? They gave the value of initial volume and final volume. So what's the value of initial volume? Vi, which is equal to 1 cubic meter, and V final, which is equal to 2 cubic meter. And the value of A equal to 1 cubic meter, and the equation they give P, which is equal to 5 e power Vi minus V over A. Here the initial pressure value is given, which is Pi, which is equal to 8 kilopascal. What is kilo stands for? 8 multiply 10 power minus 3, sorry, 8 power 10 power plus 3 Pascal. And the initial temperature Ti is given here as 600 Kelvin. By using this, we have to find what is the final pressure. So for finding final pressure, for the first part of the question, A, I'm going to use this part. So what I'm going to do, I'm going to simply substitute the value of Vi and V. So here Vi takes the value of 1 cubic meter and the V takes the value of 2 cubic meter because it's the final volume, right? So now I'm going to substitute the value to get the answer for final pressure. So therefore, final pressure, which is equal to 5 times of exponential value of Vi, which is 1, minus Vf, which is 2, over A value is 1. So now we got 5 e power minus 1 over 1. And they clearly mentioned the pressure should be in kilopascal. So Pf, which is equal to 5 exponential value of minus 1, which is equal to 1.84, because they clearly mentioned P should be in kilopascal. So 1.84 kilopascal, which is 1.84 multiply 10 power 3 Pascal. So this is the answer for the first part. Now for the second part B, we are going to find the final temperature. So what's the value for final temperature? For B part, I'm going to write it here. Let's we use the ideal gas equation. PV, which is equal to nRT. Let's we use this equation for finding the final temperature. So PF, Vf, which is equal to nRTF. Therefore, TF, which is equal to PF Vf over nR. Now I'm going to substitute the value because here the number of moles of gas is 1 and the R is the universal gas constant value. Remaining all the terms we have this information in the given. So let's substitute the value. PF just before we find the answer from the first part. So which is 1.84 multiplied 10 power 3, and then V final, what's the value? Let's just go back. V final is 2 cubic meter and V initial is 1 cubic meter. So let's substitute the value. So 1.84 multiply 10 power 3 Pascal multiplied by 2 cubic meter, and the number of moles of gas is 1, and the gas constant value is 8.314. So let's see what is the answer for the final temperature. So 1.84, 10 power 3 multiplied by 2, 1 multiplied by 8.14. We got the answer as 442. 442.6 Kelvin. So this is the answer for part D. Clear? Now we have to come for the third part. How much work is done by the gas during the expansion? So this part is very, very important, because here we have to use the integration. Because let's we go back to the question, you can see the equation at any instant during the expansion, the pressure P and the volume V of the gas are related by the equation. That means we are going to integrate the value of V. Clear? So we are going to use the formula P dV. So in part C, we are going to use the formula work done, which is equal to integration of P dV. So here we are going to find the value of V, so I have to use dV. So here the initial value is VI and the final value VF. So let's we use the equation which is given in the question. So what equation they mentioned? P, which is equal to 5 e power VI minus V over A. This equation they give. So in place of P, I am going to substitute this equation. So let's we substitute W equal to integration of V initial to V final 5 times of exponential of VI minus caps V over A multiplied by dV. So here we are going to differentiate only caps V, right? So now we can split this into 2. So if you split, what we got, integration of VI over VF, we can write this equation as 5 exponential of VI over A dot e power minus caps V over A dV. And this part is a constant because we already have this value, so we no need to integrate. So let's we take the constant term outside. So if you take it outside, what we got, 5 e power VI over A and integration VI or V final. This is our limit. So here I am going to take the term e power minus V over A dV. Now for simplify this part, we have to use the rule which we already studied from the calculus, e power mx dx, which is equal to e power mx over m. So this rule I am going to apply for this part. Clear? If you apply this rule to this integration part, what we will get? We will get 5 e power VI over A, and here when you apply this rule, we will get e power minus V over A, right, over minus 1 over A, and then the limit VI VF. Clear? So now this A will go to the top, minus A we can take it outside. If you take minus A outside, so what you will get? This equation minus 5A e power vi over a. What I did, I took this part outside. And what is inside we have? Inside we have the term, after integrating that part, we got e power minus caps p over a. Now we have to apply the lower limit and the upper limit. If you apply this, what you will get, minus 5a e power vi over a. Here we can write e power. I'm going to substitute this power, the limit. So upper limit first we have to substitute. So e power minus vf over a minus, then now lower limit, e power minus pi over a. Clear? As we already know the value for vi, vf, a, vi value in the question, it is 1 cubic meter, and v final, which is 2 cubic meter, and then the a value is 1 cubic meter. So I'm going to substitute all these value here. If you substitute, what you will get? You will get the answer for this work done, W, which is equal to minus 5 times of a value is 1, so 1 e power e vi value is 1, so 1 over 1 is 1, right? So I substitute all these values in this equation. Then inside the bracket, if you substitute, what you will get? E power minus 2 over 1 is minus 2, and then e power minus 1 over 1, which is e power minus 1. If you use the calculator here, we will get the answer for the part C, the final answer, which is equal to, so let's see what answer I will get, minus 5 e power 1 bracket of e power minus 2 minus e power minus 1. I got the answer here as 3.16. So 3.16 joules. So this is the answer for part C. Clear? Actually, the part C is a little lengthy. We are going to use the integration. You should be integrate very carefully. Clear? Now we have to come for the last part. What is the last part? We are going to find the delta x for the expansion. Use two simple reversible process to find delta s. As we already from the theory, we know the formula for delta s. The delta s, which is equal to n or natural log of v final over v initial, right, plus n cv natural log of t final over t initial. I'm going to substitute the value. The number of moles is 1, multiplied by the universal gas constant value is 8.314, multiplied by v final, which is 2 cubic meter, v initial is 1 cubic meter, plus number of moles is 1, and then this is monoatomic gas, right? So the monoatomic gas for Cv, which is equal to 3 over 2 times of R. So I can substitute the value here. So 1 multiplied by 3 over 2 times of R. So R I can substitute, multiplied by 8.314, and then natural log of T final. What is the T final answer? T final, we found the answer here as 442.6, 442.6. 442.6, and Ti value is 600. Let's see what is the answer for the first part. For the first part, 8.314 multiplied with the natural log of 2 over 1 Here I got 5.76. So 5.76 plus this side 302 takes the value of 1.5. So 1.5 multiplied by 8.314 multiplied by natural log of 442.6 over 600. Here I got the answer as minus 3.79. So plus into minus becomes minus. So 5.76 minus 3.79. So 5.76 minus 3.79. I got the answer as 1.97. So the answer for D part, delta S, which is equal to 1.97 unit for the entropy is joules per Kelvin. So this is the answer for this question. That's it. Thank you.